Our next segment will be what we call RDT, reduced downtime. It's my feelings that, oftentimes we take a look at different things that are in the maintenance of the chainsaw, but in effect, most people read through their owner's manual. It's got a big long list, and we feel like we know exactly what to do. But what we find is that if we can take and kind of slim things down just a little bit, because most people at 2 o'clock in the morning are not going to pull out their owner's manual and take a look. If it's not up here, they're probably not going to use it at that moment. So one thing that's so important, it's not the cost of the piston or cylinder or the spark plug or the bar and chain that's really expensive when it comes to chainsaw operation. It's the time that the operator loses in production and sometimes a cost of safety. So it's so important that we try to think through, how do we reduce downtime? How do we increase our productivity with the equipment that we are operating? There's 5 areas that we take a look at on RDT, and then 5 areas that we look at as far as how should the piece of equipment run. But these first 5 are just working with mechanical checks on the saw. So I'm going to run down through these, and then hands-on we'll go through them on the power head and saw here. And so the first one is we have to think about the safety features of the saw. And so there are 3 safety features especially that we want to make sure are working correctly as we start to operate the chainsaw. Number 2 is we want to make sure there's been some cleaning going on, and that's an air filter, and also taking a look at to make sure that cylinder fins and those kinds of things are clean enough so the cooling can take place on the saw. 3 is probably what we would do first, but that's a visual check over to make sure that there's nuts, screws, bolts, leaks, that kind of thing are in check. Number 4 is the starter system, the starting system. And I always ask people, I said, have you ever tried to push start a chainsaw? It's pretty hard to do, isn't it? And number 5, where the work really happens, is the bar, the saw chain, and the sprocket drive systems. So that's the areas that we want to try to discuss as we take a look at what we call reduced downtime on the chainsaw. So the first area that we're checking out here is going to be the safety features. There are 3 safety features on the saws today that you really want to make sure work, that came about, as well as the kickback testing that came about in the middle 80s, early 90s. And so in this case, we have some features that most all manufacturers, and it is a voluntary standard, but all manufacturers try to comply to this to give you a piece of equipment that's going to be as safe as possible. The first one is back here in the back. This is called the throttle interlock. And this interlock is on there so that your hand must be in the driver's seat here to be able to accelerate the chainsaw. And so that's one of the first ones. And so you want to make sure that that's operative. So that's the throttle interlock. Another one that's on all saws is called a chain catch or chain stop. And some of them are plastic, some of them are aluminum. They're usually some kind of a soft material that doesn't booger your chain up too bad should your bar rail chain come off the bar rail. But if you operate a chainsaw long enough, you're going to have a chain derail off of the bar, and that's what this little gadget here is for. It stops the rotation of the chain as it comes off the bar and shortens the distance of it back to the operator or the handle of the saw. And so it's so important that we keep a check on that to make sure it's not bent or broken out of the way. Some of the aluminum ones you can straighten back up maybe. Some of the plastic ones go. Some of them are crossed from the side cover, but they all have the same function. That's a chain catch or chain stop. The third one is a hand guard. Kind of keeps your hand from coming off the handle and going into the moving chain. And so some of them are just attached to the top of the saw body. But Companies like Husqvarna and Steel, Echo, and some of the others, they have gone another step. They actually use a band system they call a chain brake that more or less works with that handguard and stops the rotation should it get into a pinch or a kickback situation. Now, the other option that they have with just a handguard on there is to use a guard tip. And that would be a bolt-on apparatus that more or less covers the end of the bar, and it more or less eliminates kickback for sure, but it does limit the diameter of wood material that you can cut. And one of the biggest things that I see, if you're felling a tree or you get stuck in a situation limbing or bucking or cutting brush, you can't pull the chainsaw straight back out of that situation. You have to go this way or this way. And sometimes in a vertical cut, you have to be able to pick it up and pull straight up. You can't pull back out of it. But it is something that will eliminate kickback for sure. So certain applications, it's a great tool. Here we have a chain brake assembly. And what happens here is that your hand hits the guard and more or less triggers the brake and stops the rotation. You can see here that it's actually movable. If I trigger the brake, it's there. Now, hitting your forearm or hand, that's in the vertical position. A lot of people say, well, what if I have a felling cut or I'm cutting brush with it? And actually, these models actually have an inertia activated brake. From the inertia of the movement of the kick, it actually has a weighted handle system that will trigger the brake. Those three safety features. And I think about the chain brake not as much on reactive forces as I do a parking brake. In other words, if I take here, I am cutting along. If I decide to take a hand off, I basically trigger the brake on it, puts it in park. If I'm starting the chainsaw, I can have it on the ground or a clamp start. I put the brake on and it eliminates a lot of chances of that chainsaw coming in contact with me. All right, some other things that are on this anti-vibration system, which they isolate the handles from the actual bar and chain vibration. You've got also position of the handles to help with balance. You have position of the switches to be able to quickly shut the engine. A little bit of reduced kickback guide bar and saw chain. Thinking through how the ergonomics of the saw is designed with the handle angles and those kinds of things. So as we start to look at the next area, it has to do with the air filter. And every two-cycle engine has a filter, and I call it the chainsaw nose. This one has just a nylon mesh that stops the debris from going through. It doesn't have a huge filter area, so it does start to clog up fairly quickly. But it is something to where if that coating covers your air filter, it stops the airflow. Today's saws, the filter systems work very, very well, but they still have to be cleaned at some point in time. Some of them are tap off throughout the day. Some of them are hand wash, warm soap and water and let them dry. Some of them are replace. So we have to look at our manuals or talk with the dealership to figure out what we need to do on that particular filter. So that's an air filter. And another has to do with looking at number 3 is a visual over. Nut screws, bolts, cracked housings, leaks. What should you do? I always ask people, if you pick up your saw and you have a puddle of fuel down there under it, and you need to tag it out, don't use it. On handheld equipment, if it's leaking and it's dripping at all, it's going to make it back to the exhaust system and you're going to end up with a possible fire. Also, if you're missing major nut screws and bolts like your bar stud nuts or handle bolts, those things need to be repaired before you operate it to make sure nothing else is going to come apart. Next is your starter. Make sure your switch is off. You should have about 30 inches of rope to pull out. Make sure that the pawls actually take and catch correctly, and you should have enough spring tension on the rope to hold everything back in place. You just look for any frays or tears on the rope and making sure that it's in the best possible shape that it can be in. That's what you're looking for in that case. Starters are important because there's no way that you can push start a chainsaw. If that rope breaks, you're out of business. And then the bar chain and sprocket. And that really gets into several issues, and we need to make sure that we maintain those properly. And so the first thing is, and I like to point this out, when you take the side nut or nuts off, according to your type of saw, you got to remember to disengage the chain brake. Another thing that I see quite often, even without taking it off, is people start the chainsaw up, they hit the throttle, the chain doesn't turn. And they continue pressing the throttle, and the engine's trying to rev up, but it can't. You can see on this a centrifugal clutch here. And this particular clutch, you can see the shoes in there. When you hit the throttle, they sling out. They're attached to the crankshaft. When they sling out, they hit the inside of the drum, and that's what turns the sprocket and eventually the chain around. If you have that band on, or you're stuck in a limb, okay, you hit the throttle and the chain doesn't spin, those shoes are still spinning in there at some RPM. And what happens is it takes about 30 seconds and that thing will glow absolutely red. So you want to really think about making sure if you hit the throttle and the chain doesn't spin, figure out what it is. It's either brake on or something's jammed up or you've got it stuck in a limb. Make sure that you remedy that situation before you keep pressing the throttle. Next thing is we're going to check the sprocket. So I'm going to pull the chain off of here, and I can inspect that as we either come off or go back on to make sure that all my 5 parts are in good shape and drive links and all look pretty good. One thing on match of the sprocket, and this particular one here has 2 sprockets. You have a drive sprocket on your back side of your drive drum, and then you have another sprocket on the bar tip. Both of those have to match the pitch of your actual chain. And so a couple things just quickly, and I see this to be somewhat of a problem, especially with storm cleanup. You have to go back in and get another bar or chain to go on your saw. You really have to take the whole thing in, or you have to know what the pitch and gauge is. The pitch would be a measurement between 3 rivets, over 3 rivets divided by 2. The gauge is the thickness of the drive link that goes down into the bar rail. And I see those mismatched quite often, especially on pole saw situations. So you want to make sure that those match. One place you can find it, if you have the original bar on there, it's usually engraved into the side. Like this one is a 325 pitch, 0.325 of an inch. It's a 50 gauge, and there's 66 drive links on this particular combination. Now, one thing on the sprocket you want to check, and this one actually, a floating rim, has a wear indicator on it. And that little mark lets us know when the wear gets down to about 28 thousandths of an inch. And what it is, they can't harden that sprocket material all the way to the middle because it's going to be brittle. So they harden the outside areas. And when you have wear till it gets to that 28 thousandths, it's pretty slim. But once it gets to 28, now you're in soft metal, things start to wear quicker. So you want to think about checking that on a regular basis. And if it starts to look about the thickness of your thumbnail of an indentation, you want to think about you maybe need to look for another sprocket pretty soon because it could start wearing pretty fast. The other sprocket up here on the bar tip, when it starts getting really pinpointed, you know that it has wear. But this one looks pretty good. It should turn freely and should be tight to the bearing. We want to make sure that we check that. And then the next thing is the bar rails. Always think about using gloves with them. Is these bar rails, they have, I call it a peening action or a flaring that starts to happen. And so it's just a thin peening that happens on the edge, and without gloves on, it's sharp as a razor. So you want to make sure that you have gloves on. But you can take that flaring off with a flat file, or you can use a bar dresser like this, 90-degree file holder, to be able to take that off and also dress the rails of the bar. The actual cleaning can be done with anything that'll go down into the rail, putty knife or in rail cleaner or this depth gauge plate. And make sure that you clean all of that out. And I always tell people, I say, you know, it's amazing. I have been told it's about 450 degrees is the average bar and chain temperature. That's with sharp chain. If you go up to dull chain, it could go up to as much as 1,000. So I always tell people, you know, just at good sharp chain, if you were to put cookies in an oven at 450 degrees and leave them for a week, what would they look like? And so here the same thing. You get chips and oil that's built up in here at 450, 500, 600 degrees. It starts to cook out, and you end up with carbon that's going to stop up the holes and really inhibits your flow of oil around. So you want to make sure that you keep those cleaned out quite a lot. And you can also rotate the bar to even out the wear. So that's something that you can do. Each time you take it off to clean it, you can flip it, and it kind of increases the life of the bar because it evens out the wear. And then one other thing too, people ask all the time, I don't think my oiler's working. My bar's smoking. And I had a gentleman that was up in West Virginia, and come to find out he was a welder, but he was sitting back in the back of the room, and one person said, I don't think my oiler's working, my saw, my bar's smoking. All I heard him say was, metal doesn't smoke. And what he went on to explain is, you know, if it's smoking, you're probably burning off oil or burning off paint. And so it's getting too hot for the oil to be able to handle. So you want to think about that, is that you want to try to keep those temperatures low. And what raises and jacks that temperature up is dull saw chain. You start pushing on it, metal against metal, it starts to really affect how well your bar heat's going to be maintained. So you want to look at that, make sure everything's good. Then going back on here, and something that I've learned is, if you'll just set your chainsaw flat, no matter what the brand, set your chainsaw flat, and then take and look at your chain. And you want to make sure that your depth gauge is forward of the point on top of the bar rail. So what I want to do is, I'm going to go around the drive drum, and I'm going to feed my chain into the sprocket. Then I'm going to lay it into the bar rail. I come out here, and some of you have the adjuster on the side. You got to pick it out and push it back. On this one, the adjuster's on the outside cover. So all I do is just push it back, and then I get around the tip of the bar. And then next thing I do, I grab and I pull up and go onto the adjuster. It's just that easy. You can do it almost one-handed. You don't have to turn it up sideways and try to hold it with 3 hands. So it makes it so much nicer and so much easier to think about putting your chain and bar on this way. Next thing is to take most chains off, bars and chains off. You don't have to unadjust, I guess you'd call, or loosen the adjuster. But going back on, if you have the adjuster on the side plate, you have to adjust it a little bit. If it's on the crankcase, you can just pull it out onto the adjuster. But here on this one, I'm going to have to take and back it up just a bit till it goes into the hole. Then I start my adjusting nut here. Some saws, like I say, have 2 on there. I go in just thumb tight. And then what I want to do is, I want to adjust this until the chain is proper tension. And what I want to do is, I want to turn this adjuster, some of them on the side, some up in front, until the chain just touches the rails. You don't want to have your chain to where it hangs below the bar. It should snap back to the bar, but then it should turn freely around with a gloved hand. And if you have that situation, you're set to go. Too tight, you have heat and friction. Too loose, it starts to bundle up. If you remember, we talked about on saw chain that if you take the chain, it has to move up and down and side to side to actually take the chip. So here you want proper tension so that chain is actually coming up and turning and going to the side to produce the chip. So many times people push onto the saw. When you do that, it slows the RPM, it slows your cut down, but it also creates a lot of heat. The best thing to do, and we'll talk about it in our outside presentations, is to pull back slightly on the saw and let it cut. Let it do its own thing. I mean, you can go up against the bucking spikes to kind of feed it through, but don't apply pressure. Let your chain do its work. So that's chain, bar, and sprocket. We have looked at the starter system, visual over nut screws, bolts, cracked housings, leaks, making sure the air filter is clean and the cylinder fin areas are blown out and clean. And then also the safety features of the chainsaw. And so that saw is mechanically ready to go.